Most of my expertise is in a field called gravitational lensing, which is a part of astronomy in which when we look at very massive objects that can bend light around them. And so if we have a more distant galaxy and like a big galaxy or a cluster of galaxies between us and it, instead of seeing the light from that galaxy traveling on a straight line to us, we see it get bent around that thing between us. And in doing so, we get to both magnify the background galaxy and learn more about it, as well as learn about what the mass, how the mass is distributed in this foreground galaxy. So astronomy is what we tend to call basic research, in which what we're trying to investigate is the way that the universe works, right? And so I'm using gravitational lensing as a tool to investigate how the universe is expanding and what some of the basic parameters of the universe are. What we're trying to do is discover how the universe works. And what we've been able to figure out so far is that we think we have the basic physics down, but if that's correct, we're missing 95% of the universe, and that most of it is this dark matter stuff and even more of this dark energy stuff. And the hardest thing to do is, just in terms of cosmology, is the whole idea of the expanding universe. And even in like Astro 100 courses where we try to explain this, we have to simplify it down, because it's the sort of thing that, yeah, it's, you know, on physics you go down to very small scales and you get down to quantum mechanics and the world works in just a different way and it's very hard to understand. On very large scales, the universe also works in a slightly different way. And we're basically at the same step now that chemists and physicists were 200 years ago, in which they discovered that the world was working in ways different from how they were taught. And they were trying to go through the steps of figuring out what is going on. And we're just now in that stage in cosmology.